I'm Scott Behrens, and I'm here with Lakshmi Sudheer. We both work at Netflix. Lakshmi works in application security. I work on the product and application security org. And yeah, we're here today to talk to you about securing your company's crown jewels while the world watches the crown. Work with a bold, really the core of our data security program is to ensure that data consumers and producers can access, use, and move data across all data platforms in use with the appropriate data protection guardrails in place. And this is a really powerful statement because effectively, in order to achieve this goal, we have to be very strategic about how we secure the data platform such that we don't overly burden our end users. And at Netflix, we have a big culture that focuses on freedom and responsibility. Freedom to choose how to produce, store, and use data. But we also ask our developers and data producers and consumers to be responsible with that data and safeguard it for our customers and our partners. And why data? Why should we focus on data? You work with a lot of application security folks, and we often work at the edge on external applications. Well, in 2017, The Economist wrote a powerful paper on the world's most valuable resource no longer being oil, but data. And so if data is more valuable than oil, we should definitely focus on it. However, oil, just like data, requires refinement to be more valuable. And it's really a primary business driver for Netflix. It's what allows us to make great content and bring you all the joy for your favorite shows and things like that. But there's problems with this on the information security side. As an example, data and misconfiguration of data stores is one of the biggest problems regarding data breaches. And I think it's kind of interesting. If you look at the top here, we literally have a 10 best of for S3 breaches. Reached a point where we're making best of lists for these types of compromises. And in Verizon's 2019 CX survey, they found out that roughly 29% of people would never use a brand again if they were breached. Let's just assume that that's off by some margin of error. Let's assume that only 15% would never use your brand again. That's still a lot of customers you would potentially lose in a breach. And we have ever-changing regulatory and compliance needs. And so data platform and data security strategies need to take that into consideration and have the nimbleness and agility to adjust to those ever-changing standards. Another challenge that we face is how do data platform producers and consumers prioritize work? Do they prioritize privacy work? Do they prioritize security? We can imagine even like a third arm on the scale here for efficiency or productivity. So there's a lot of things that go into the decision-making process for how you choose what to work on. So taking those problems into consideration, we realized we needed an approach that was quantifiable. And so we ultimately landed on is a risk-driven, data-centric approach that aims to unify both security and privacy initiatives for data platform owners, producers, and data consumers. I'm curious if you've all heard of FAIR. I can't see you in the audience, but I can kind of imagine maybe a couple hands are raised. FAIR is a quantitative risk analysis framework that really defines the probable frequency and probable magnitude of future loss. So effectively, what we can use the FAIR framework for is understanding what the frequency, how often will that thing occur, and when it does occur, what the cost of that thing will be. So let's walk through some examples on how we could use risk in the data platform space to make better strategic decisions. The first part I want to really focus on is just walking you through the risk assessment lifecycle. With risk assessment, our first goal is to identify a risk scenario. The second part is forecasting and collecting data. And really in this part, we've built this scenario out. We're working with forecasters to kind of look at the information we've collected and maybe previous incidents, external information, and they will forecast the frequency and magnitude of that given scenario occurring. We'll then perform that analysis, effectively running a number of Monte Carlo simulations, effectively imagining that this incident was to occur. And we run that simulation 20,000 times. And then at the end of that, we report on those findings to help make better strategic decisions for investment. So how do you build a risk scenario? It's 4 components: assets, threats, effects, and methods. So an asset can be anything of value that can be impacted in a way that results in a loss. So as an example, an asset could be core PI, credit card numbers. A threat is anything that's capable of acting in a manner to harm that asset. A threat could be hacktivists, malicious adversaries, rogue insiders. Effect is the CIA triad. And method is kind of synonymous with technique. So this could be server-side request forgery, unsafe deserialization, misconfigured S3 bucket. So let's look at an example of a risk scenario. We have here external malicious actors impacting the confidentiality of core PI via S3 misconfiguration. So we have the threat, we have the effect, we have the asset, and the method. I'll be sure to post our slides, because we have a link for a fair scenario builder. It's like a sheets that you can open up. And you can also has a little Mad Lib feature where you can list out a bunch of assets, threats, and effects, hit the refresh button, and it'll like spit out risk scenarios. They're often not very good. They're sometimes whimsical, but occasionally they'll actually create a relatively compelling scenario. I wanted to link this just more to get your mind sort of prepared to think about risk scenarios this way. So how are we actually approaching priority? The first thing we kind of realized when we started on this journey is we really needed a little bit more insight to improve our analysis. And we'll talk a little bit more about how we get that insight data in the next few slides. We also wanted to focus on risk analysis across all of our platforms, because we realized that if we looked at all of our data platforms, we could kind of look at those analyses relative to each other to make investment decisions on where we should do security control work. And of course, alignment with our stakeholders. It's really important to get their buy-in and make sure we're collecting their feedback. So let's talk a little bit about data insight. Today, we're going to be focusing on data like customer data, studio data, employee data. We'll also be focusing on structured data stores. So data stores, databases, caches, and logs. We have focus areas on unstructured data, but we're going to keep that out of scope for today's discussion. So let's talk about how we get insight. We have 3 various strategic initiatives that we focus on: cataloging, detection, and lineage. So with cataloging, it's exactly what it sounds like. We want to really know what data sets we have, ownership information around those data sets, and make sure they're tagged with the appropriate data categories. And so here, a very redacted sheet kind of shows that we have our catalog times on the left, things like Elasticsearch, RDS, or S3. And on the right, data categories, data size, information like that. So our goal is to continue to improve this data classification process so we can understand all the data and the types of tags and ownership of those data. Let's talk a little bit about detection. And I'll admit this is a very noisy slide, so don't worry, we'll step through each section on its own. But detection is really a supplemental control to cataloging. When we can't get cataloging right, or if we misidentify information or information sort of spills from one place to another, detection gives us a means to make sure that we're tagging that information appropriately. And the way we perform that is by capturing samples of data. We work by, let's use RDS as an example, setting up RDS to receive the change capture information. You can kind of think of this as like read replicas. We take that information and we stream it into Keystone. Keystone is a real-time data processing framework. And what we do with that information is, in real time, we run it against our sensitive data detection library. And we run this across all these various data stores and aggregate that into another Keystone topic. And we're able to do a lot of really cool things with that data. We can report on it for privacy and security teams. We can alert folks that maybe they haven't tagged their data correctly and that they need to update some information. And ultimately, we write all that data back to our data catalog so that we have a more comprehensive catalog. Let's talk a little bit about lineage. So lineage is really kind of understanding how data moves through your environment. And lineage is actually really important for us to be successful at that key goal that we stated in the beginning about being able to move data freely through our environment with the proper security safeguards in place. And what we mean by lineage is really understanding the ownership information of the data, what kind of systems are accessing the data. And if we have that context, we can do things like propagate access control and ensure that we have this consistent security story as data moves through our environment and all the various ways that data producers and consumers work with data. So now that I've given you a primer to sort of our environment, how we get insight, and how we use risk to sort of identify the areas that we want to focus on for our security treatment, Lakshmi is going to discuss with you all on how we achieve the security goals that we described in the beginning of our presentation. Lakshmi, take it away.
Thank you, Scott. So now that we went through the process of our risk assessment, we got like quantification of how much risk we have for various scenarios across data platforms. And we understand our data as to like, oh, there's core PI, there is some other class of data in all of these data stores. The next logical step was for us to figure out, how do we treat this? We have all of this data, but how do we address this? And that's when we built a data security program. But before stepping in too much into the program itself, I just want to give folks a sneak peek into like, what's our philosophy when we do this? At Netflix, our motto is to provide joy to our members. And you may be asking, how does that translate to your data security program? As an InfoSec team, we want to enable our data producers and consumers to have that freedom to choose how to produce, store, and use data by making security as easy as possible, streamlined with our ecosystem, such that it causes less friction. And this is done through like these 4 pillars, as we call it. One of it is the most commonly spoken secure by default. Any central infrastructure, we invest on making it secure by default. And for all of those, we are big on building our own security solutions, which gets completely inbuilt into the developer ecosystem. And we call that paved road solutions. We use that. And the counterpart to that is also privacy. Scott earlier mentioned that teams do get sometimes overwhelmed with like different asks from different folks from InfoSec or like privacy, legal, and all of that. So we have tried to combine that also to be a part of our philosophy where we look at data holistically. Responsibility or stewardship. Scott touched a little on how we capture ownership data, but we have this distinction where you are the owner of your data and your app, but we as security, we are responsible to provide you with the right recommendations and the right solutions to be able to produce data and use data securely. Minimization. Of course, use of data, just use the limited amount of data that you need to make a decision. But again, we also view it from an InfoSec standpoint that what are the controls that actually make sense to reduce risk? So that's also one of the pillars we think about when we think about data security. Now, when we thought about how do we secure data, of course, there's data in use, which is analytics. You have access, which are endpoints from where you access data. You have like data in transit. Then you have the source of truth, which is data at rest and storage. And this storage also has structured and unstructured data. These are the horizontals, how we split it to focus on working through our data security program. For the sake of today's conversation, we will be focusing only on the structured data stores here. To start with, we said it's a risk-centric approach towards like securing our data. To do that, what we did was we took the top level risks that we got from the risk assessment. Then from the catalog, we derived like, what are the classes of data? And we built out a control matrix, which for both security and privacy together with all of these controls and thinking about which control here actually reduces maximum risk. That way, we prioritized these controls. You can see P1, P3, P2, and all of that there. So we went through all of this and we made that these are the recommendations probably that we would give or we would build upon. The next step after we created this control matrix was to apply it to all of our data platforms. Now, when we applied it to all of these data platforms, we determined like, okay, these controls buy down maximum risk for these data platforms. And that helped us align as to like, where are the huge gaps in our ecosystem, right? We discovered that, and it helps us nail down like investment areas for building controls or figuring out what's the security story. You can't do everything. I mean, you can't address everything, and that this helped us prioritize it in a very informed way. Today, let's step into some of the controls that we worked on and how we thought about it. Firstly, authentication. As all of us know, identity is what most of security is based on. So it was really important we got our authentication story figured out, our identity story figured out. And what made it challenging with data stores is data stores are there at various layers, right? Like you have TCP data stores, you have like gRPC data stores, you have HTTP data stores. They're at various layers. They also come in different flavors, right? You have some AWS managed, which have a different kind of authentication. You have like off-the-shelf data stores, let's say CockroachDB is something which has its own protocol and own authentication as such. So with all of this variety of data stores, it was really hard to figure out like what is the right kind of authentication that we can have here. For us, as I was talking about the paved road solution and what we provide as a security infrastructure, we already had a mutual TLS solution, but to expect each of our data store owners to go and configure that to work with our mutual TLS felt like not really a reasonable ask. And, it's so much work, and that was really not going to work at scale. One of the other things is we realize most data stores rely on usernames and passwords, and that way we lose the ability to get strong identity. Let's say in case of an incident, we are trying to figure out did Scott actually access this, or was it Lakshmi? That's really hard to determine when passwords are the main component of like establishing identity. That's when we came up with the solution, which is developed by our data platform partners called Data Gateway. I've named it Security Proxy because it's essentially a proxy, a combination of a forward proxy and a reverse proxy. Now, this proxy fronts all the data stores and manages the connections to the data store. All data stores owners have to do is they go to the central team that actually manages this proxy and builds connections to, let's say, MongoDB or like RDS or any of these data stores. And for you to be able to just connect to it, all you do is spin up a local host or a forward proxy and connect to this reverse proxy that manages all incoming connections to the database. So this way, this security proxy, again, utilizes our already existing paved road solution of mutual TLS. That way, now if Revenue App is trying to talk to persons DB here, it first hits the security proxy, and the security proxy, because you have the certificate, determines that, oh, it's really Revenue App which is requesting. And similarly, even the other way around, right? Like Revenue App knows that it's talking to the security proxy of persons DB. This way, the security proxy, which is called Data Gateway, became our paved road authentication for data stores. And it relies on our already existing paved road authentication infrastructure of mutual TLS. That's how we achieved, and we are investing on authentication for data stores. Authorization is complex. It's really, really hard to achieve the right level of authorization. Well, we are also trying to figure out like what's the best way, and how do we get that cadence between like least privilege to like complete open access. We think about it as like right side security. I will explain that in a bit as to what I mean by that. You remember instant joy to our members? Now, let's say a new season of your favorite show is going to be launched at 12 a.m. tonight. You're all set with your popcorn. But we have a streaming service that always, launches new titles. But we know that rarely, let me just throw in a number. Let's say once in 3 years, there is a resiliency team or some other team that may have to get involved for troubleshooting. When I think about this content that is going to be launched and this team, I would probably lean more towards having a right size policies, which also has this resilience team included, such that we don't have friction, we don't cause friction to the business, but it still buys down enough security by adding this one team. It doesn't really increase our risk by that much. And of course, this varies scenario by scenario, but this is an example to show how we are thinking about like OTC. What's the solution for this? I'm sure you would have guessed it's our magical data gateway. So this security proxy already like validates identity. So it has the identity of the user or the application that's requesting to connect to this database. And we already have our authorization, central authorization, our paved road infrastructure called Gandalf, which actually does like ODZ policies, manages all of these policies. Now, what the security proxy does is when revenue app talks to security proxy, it first validates whose identity it is. Then it asks Gandalf, which is our central RZ infrastructure, that, hey, is this app allowed to actually talk to person's DB? And if it's an S, of course, it forwards the connection and our revenue app can now talk to person's DB. So if you think about this, even if passwords are compromised for a data store, the attackers still won't be able to access the database. Because let's say I'm an attacker and I want to actually, I get passwords to some database that Scott has access to. I would have to have this cert as well to be able to bypass this. Now, let's look at how does it look from a developer's laptop? With any new solution, there's always this migration effort. There's always this learning curve. One of the cool things I really like about Data Gateway is that the ease of actually connecting to a data store. Now, in case of authorization here, all I do is I spin up a forward proxy. I talk to the reverse proxy that is fronting this data store. And as I said, we have a payload solution for mutual TLS. So the cert is already in my laptop. This reverse proxy validates that, hey, Lakshmi is the one connecting to this, and does she have access? It checks with Gandalf, which is our RZ infrastructure, and allows me access. So there'll be a demo in a few slides for the setup. Let's watch that in action in a bit. Now that we've spoken about RZ and authentication, one of the other controls that we thought a little about was encryption. When we thought about encryption, we wanted to understand what risk scenario are we trying to protect against the most? What's the highest risk? Is it someone stealing our data from a data center? Can happen, but the probability is really, really low, which makes the risk really low. So encrypting database address doesn't really buy down that much risk based on the risk cover here. So we thought that we should reserve our recommendation about encryption to only when data stores hold really, really sensitive data and wherever necessary. And say SSN, right? Of course we need to encrypt it, secure it, and do a bunch of things with it. So that's how we thought about encryption. For encryption, we already have a payload solution because we're talking about just data being encrypted and inserted into the table. So we did not think we have to invest on a central infrastructure or figure out what is the solution at scale for database at rest. Of course, security is defense in depth, and I just wanted to call out that we also focus on control plane hardening. By control plane, how I view it is it's that part of the infrastructure which actually configures the rest of the data plane, right? So we are also investing, it wouldn't mean anything if you leave your AWS admin console open, or you put all these application controls and actually open up, you have broader security groups. Similarly with Google Console or anything else. We're also working on downsizing security groups, investing more on account isolation and other efforts. Application security controls. Similarly, you have to have application level controls, protect yourself from OWASP top 10, top 100, all of those vulnerabilities that I'm sure all of us here on this in this conference are pretty familiar with. One of the things I wanted to call out that Asta mentioned in a keynote talk this morning was asset inventory. Now, that's the source of truth for all our assets. It has applications, data stores, and the connections and the flow logs and all of it. We are hoping that we can use in the future all of this information to see where do we invest on. We already rely on it for some of the self-service things which show security health of applications, what's the risk score. And this can also feed back to our risk assessment as it gets updated, and we can get risk score per app, per data store, and see where do we invest on hardening. What's the right place to invest? Let's get into the fun part. Here we have our demo of Data Gateway. Now, awesome. So here, what I'm doing is I am creating a Postgres client, trying to connect to an RDS instance with just the username and password. If the username and password are right, I should get access. Looks like I have access. Now, let's look at how it would look like from a developer's machine if we are using Data Gateway. Remember, my laptop already has the cert. So all I have to do is type in this command to spin up a forward proxy such that it can connect to the reverse proxy of the RDS that I'm trying to access. Here you see I have my forward proxy spun up. We can just check if my forward proxies, the forward proxy container, just to make sure that it has been spun up. I see that I have my forward proxy. Now remember, without ODZ, I shouldn't be able to access this. So let's try to refresh and see if I can connect. I'm just changing it to localhost because my forward proxy is on my localhost. Looks like I still have access to this database, which means that I am authorized to see this. Yes, this is our authorization system, and you can see that I was allowed to access this database as a user. Let's update it, remove me. And now, though I have the same username and password, I shouldn't be able to access because the Gandalf policy doesn't allow for it. It didn't allow me. We can even try with spinning up a new client and trying to actually access it. We can put in the same username and password, and it still shouldn't allow me because though I have the password, the policy has not been set for me to be able to access this. Awesome. So this is what Data Gateway brings us. Why did we invest on a central infrastructure, right? Like, why do we consolidate all of this? One of the things this buys us is we can build at scale. We have a new off-the-shore database that comes in. It's just this team that builds out this configuration to be able to work for the security proxy. Then it's easy for the asset inventory example I said to go and determine okay, this data store is in front of data gateway. We have easy monitoring, and we can also fix at scale if there's any issue. Not just investing and building out a new control for the paved road solutions, but we also have opportunistic investments that we make time to time. Data mesh is one of the projects we are really excited about, which is going to be the future for our real-time data infrastructure. So whenever data moves from A to B in the whole of Netflix in the future, it's going to use data mesh. So we started investing early on secure by default access control schemes. But one thing that I'm very excited about is propagation of tags. Scott mentioned that we are tagging each data set and trying to understand what data we have. Usually we lose the context when data moves from A to B. But this provides us an ability to invest on propagating this tag so that once the data set is tagged, it is always going to be tagged for the rest of its data life cycle. With all this, I must say that none of this would have been possible without our amazing partners on the data platform world, as well as our InfoSec teams. So to provide a little glimpse of how we do partnerships at Netflix, Scott is going to talk about it a little.
So I'm going to take a second to walk through how we approach partnership. But for a deeper dive, and we'll share out our slides as well, you should check out Isha Kinniker's and my talk from AppSec Cali 2019, where we'll walk through our partnership program in greater detail. Really, our partnership focuses on a couple of key areas. The first is unification. We really come together and bring all the information security teams asks into a single place and present that to our partners so that they're not having to interface with a lot of different people. We also find ways to take our work and build it into their strategies. We want to show that security is not something extra that you bolt on. In a lot of ways, security allows you to drive faster and drive safer. We also are feedback focused. We spend a lot of time making sure that our customers' needs are heard and that the things that aren't working well in the partnership are addressed. We're pragmatic, meaning sometimes we'll choose to lean a little bit into risk if we believe it can improve the partnership and therefore decrease risk over time. And our partnerships are really strategic. We don't go in and just do a bunch of penetration tests and leave. We try to actually build out a relationship that lasts so that we can drive down more risk holistically. So we have some future ideas I'll cover briefly before we conclude our talk. The first is really around effort scanning of paved road or control adoption and risk factors. So we want to start to scan our entire environment to see where we not have TLS configured, where are credentials in the clear, where are we missing data gateway, and ultimately use that to drive more adoption of our tools. We also want to perform risk analysis at scale. That's through a program called SAGE. I'm currently shopping around a talk for that, so would love to get into that in greater detail. But effectively allows us to take a quantifiable risk model using a machine learning algorithm we built to do risk analysis at scale. We also want to right-size access over time. So based on usage patterns, we want to take that information and make policy recommendation and improvements based on things like usage, environment, and risk. We're working to make it easier to self-serve our secure database program, and as Lakshmi mentioned, the propagation of access control across our streaming infrastructure is in flight. So with that, I'll conclude on a couple of key points. By taking a risk-based approach, especially if you have a very low infrastructure, you can ensure you're working on the right things. By moving your data security work into sidecars, containers, aka proxy, aka Envoy, you make it easier to secure the polyglot nature of the data platform. And by focusing on building a strong partnership with your data platform teams, you can continue to drive down the risk posture, creating a great relationship with them, and ultimately, for us, achieving our key goal of letting data producers, consumers move data freely through our environment. And with that, we've concluded our talk. Thank you so much for your attention. We'll be sure to share out the slides with some of the links for some of the content that you can play with, like the scenario builder for risk. Thank you very much.
All right. Thank you guys both very much, Lakshmi and Scott. Thank you guys for that wonderful talk. So now get into like a quick Q&A here for you guys. Now, one part that I think people are interested in is that security controls piece. Now, you talked about a little bit about what it looks like in the future to try to identify some of those gaps. But then how would you guys go about measuring like effectiveness of some of these? Like you kind of showed that breakdown there. Here are some of the controls, but how do you then measure the effectiveness of actually addressing what you guys are seeing?
Lakshmi, take it away.
Sure. So that's a very good question. We started off with our risk assessments being more like, oh, this is the risk, this is the threat scenario we're worried about, like a breach of confidentiality because of an accidental error. When we started that, the other aspect of it that we did was like having even a controls package and saying that with all of these controls, how much risk do you think it would reduce? How would the frequency reduce? So we got these numbers of, let's say, I don't know, 100,000. That's a really low number, I guess. But let's say 100,000. Then with controls, let's say we could reduce the risk to 50,000, right? So that's how we determine that we can use these controls to actually buy down the risk. And of course, it's always a combination of like the risk assessment and our informed gut. Now, authentication, let's say we know that authorization would bring down the risk, then we need authentication to achieve like authorization there. So we started investing incrementally using both the risk assessment results and our informed gut. And once the controls package, which is like one to, let's say, authentication, authorization, access logging, could solve it, we just prioritized among them. Like, what do we want to prioritize first? That's how we approached that.
All right.
Yeah, and actually, I'll just build on that. I can build on that just a little bit. So in regards to how we actually measure the control adoption, what we're really looking to do is leverage some of our security scanning automation framework. And specifically, let's say that we have goals around authentication. What we're going to do is have our scanners go and make sure that the authentication mechanism is MTLS, that it's using data gateway. We're also going to work on automation to ensure that there's a proper access control policy. And so, this is work that's currently in flight, but what we believe that'll allow us to do is have more confidence and correctness of the control adoption. It's really hard to get complete assurance, but our goal is to continue to improve our confidence in that assurance over time.
Absolutely. And so a little bit about the risk assessment piece when starting, the idea of coverage. So how do you guys go about planning where you guys are going to be starting your risk assessments, or, hey, we've done these ones, so now that means that we can focus on these? Well, can you talk about like what that coverage looks like for you guys?
It's a great question. And I can tackle that one since I've been working on some of the risk stuff. Really what we've been looking to do is we have a lot of platforms, over 20 different data platforms that we have to focus on. And so a little bit of that is really kind of thinking about what is the criteria to perform a risk analysis. We look at things like the total volume of data, the types of data classifications, evidence of previous incidents, total number of users, previous security vulnerabilities. A lot of criteria kind of goes into that selection process to kind of determine where we go next. And we don't always get it right, but our goal is to continue to improve and do more risk analysis over time, eventually leading to the place where we've done all the analyses. So a little bit of our informed gut combined with those types of facets go into our assessment selection process.
And then if I know anything about Netflix, you guys will eventually get to the long tail. But all right. Thank you guys.
That's
sorry,
right.
that was very cool. I don't mean to dismount you guys at that point in time. But okay. Thank you guys very much for joining us and sharing that talk with us. Again, aloha and a mahalo to you guys, and we hope to host you guys, in some other fashion with Locomoco Sec in the future. Please take care.
Thank you. Aloha.